Okay, I thought we'd go over a few of the problems from Parametrics Worksheet 2. I'll talk through a few of them we can do together. Just making sure that you can graph this one. So I filled in the chart. So if you filled in when t is 0 to 2 pi, you should have gotten those answers. And so when you go to graph them, you start at 4, 2. Then you go at 3.71, 2.9. So you should notice that it starts to go down and it gets to 3, 1. So when you graph this, the arrow should be showing that you're going clockwise. It's hard to see my arrows, but they are going clockwise. And it looks like it is a circle with a radius of 1, which makes sense because there's 1s in front of here. And it got shifted over 3 to the right and 2 up. The x's got added to 3, the y's got added at 2, so that's why the center is at 3, 2. This negative, you'll notice that's kind of the reason it went down first. Because normally the sign, would be positive. If it was plus sign, it would start here and go up. But because it's a negative sign, it went in that direction. So that's why it went clockwise instead of counterclockwise. All right. The problems where you're eliminating the parameter. Again, we should start to recognize two things. We should start to recognize what that should look like. It is going to be a circle because these two numbers are the same. Its center is going to be at 0, 0 because there's no adding of the x and you didn't add anything to the y. And the radius will be 3 because the x's got stretched by 3 and the y's got stretched by 3. So we should know, looking at that it's a circle. But we also want to be able to put it into rectangular mode. So to do that, we have to solve for the cosine of t. So cosine of t is x over 3. Sine of t is y over 3. And we know that if I take cosine squared, so I took x over 3 squared, plus sine squared, y over 3 squared, that has to equal 1. And I just kind of squared those. So I squared the top, x squared over 9, and this I changed to y squared over 9. And then because it looks like this and these numbers are the same, I can multiply by 9. So I get my equation of the circle. Center's at 0, 0, because I didn't add anything inside the function. And this is r squared, remember? So r is 3. Okay, so in both of these, you should kind of be able to tell this information down here. All right, so let's look at 3. 3, I think, kind of messed a few people up because of that 2t. But you still want to get the sine of an angle. So sine of 2t equals x over 4. Cosine of 2t equals y over 2. And even though it's 2t, the sine squared of any angle plus the cosine squared of that same angle, as long as they're both 2t's, I'm okay. I know that this squared plus this squared has to equal 1. And so it's an ellipse with the center at 0, 0. Now, I always write what the a and b are. A is, remember, the vertical stretch, or the horizontal stretch. It's with the x's. So the x's are going to get stretched from the center by 4. The y's are going to get stretched by 2. It's the square root of that. That's a squared and that's b squared. So if you were to draw the picture of it in rectangular mode, you would know it's at 0, 0. The x's are going up 4 units. The y's are only getting stretched by 2. So it's going to be the ellipse that's kind of stretched horizontally. Now you may want to throw that in your calculator and have your t's go from 0 to 2 pi, like we normally do for sine and cosine. And if you kind of watch it, you should see it goes around twice because of that 2t. So really, what does the 2t do in the parametrics? All it means is that when I go to set my t's, I really only have to go from 0 to pi. Because now, if I go from 0 to pi, and I'm going to double that t value, that's technically still going to go from 0 to, when I plug in t as pi, it's going to go from 0 to 2 pi. So all of this does is just says, if I only need to go around one rotation, I only have to set my window from 0 to pi. That's the only thing that 2t does. So in converting, it has nothing to do with converting into rectangular. Because remember, in rectangular, we lose that whole going around the circle piece. So when I look at this, I just realize, yeah, it doesn't, I'm not going to see that. The other issue is you might want to throw these in a calculator just to see what happens. Realize that the sine is with the x and the cosine is with the y. So you might want to take a look at that and see how does that affect the way it goes around the circle. around the ellipse. And I'll let you do that on your calculator as a little investigation. So if you need to stop right now, stop the video, throw this in your calculator. You can just go 0 to pi if you want, or you can go 0 to 2 pi, and then watch the rotation of it and ask yourself, what is that sine with the x and the cosine with the y? How does that affect it when it normally is the cosines with the x and the sines with the y? All right, 4, just go through 4 real quick. This already is, x is the cosine, so we didn't have to do anything with that. Y equals 2 sine squared, so I divided by 2. Now realize that's sine squared. So when I say, okay, cosine squared, so I had to take the cosine and square it, plus the sine squared, which is just y over 2. So now the sine squared is y over 2 equals 1. So cosine squared plus sine squared equals 1. And then I saw that, oh, that's a parabola because I only have one thing that's squared, so I multiplied everything by 2. I subtracted 2x squared. So this is a parabola. It's going to open down because of the negative 2 in front of the x squared. And the x's didn't get shifted at all, but the y's got shifted up 2. So the vertex is at 0, 2. Okay? All right. Now, this is kind of the new one we hadn't talked about, which I think probably stumped some of you. It had secants and tangents. So what you have to remember is there is a trig formula for secant and tangent. Remember, it's tangent squared of any angle plus 1 equals the secant squared of that same angle. So that's what we're working with instead of sine squared plus cosine squared. So I first have to get the secant by itself. So secant is x over 4. Tangent would be y over 3. And so now I know if I take tangent and square it, y squared over 9 plus 1, I have to get the secant, which is x over 4 squared. So I get y squared over 9 plus 1 equals x squared over 16. All right, so now I need to decide what does that mean, because that's not an ellipse, it's not a circle. So we haven't talked about hyperbolas yet, but hyperbolas are like ellipses, except for instead of a plus sign here, we have a minus sign. So I want to get it to look like an ellipse kind of. So I want to leave the 1 over on the left side, and I'm going to subtract y squared over 9. So notice how this looks like an ellipse, except for instead of a plus sign, now there's a minus sign. And so what that does when we're in rectangular mode is when you see that you still have both two squares and they're not the same, so you have this A and this B like we did with ellipses, we need to look at that and realize because there's a minus sign, now it's a hyperbola. And so a hyperbola is going to have, okay, so it has a center at 0, 0. So let me draw on the axis. So there's the axis. This says the center is at 0, 0. Because again, nothing's getting added to the x or y. The A stretches 4 and the B is 9, or is 3. So all that means, it's kind of like the ellipse, so we still say that that's the A and that's the B. All that means is when I draw these asymptote lines in, that's what these things are. When I draw the asymptote lines in, it has a slope. The y's are getting affected by 3 and the x's by 4. So it just means from my center, I have a rise of 3 and my x's are 4. So my slope of this line would be a rise of 3, a run of 4. That's all that means. Not that you need to know that. You just need to know that it is a hyperbola. Hyperbola. And the center is at 0, 0. There's the equation. And when you look at that hyperbola, when the x1 is squared, that comes first. This x squared is the positive one, and you're minusing the y squared. You just need to know it goes like this. It's going to be a parabola that opens left and right. That's the piece you should know. So you should know when there's a minus sign, it's a hyperbola. When the x squared comes first, that's the positive value. It's going to open left and right. Okay, and then let's just finish up the front page. With this one, it was an ellipse, so I solved for cosine t, I solved for sine t, cosine squared plus sine squared is 1. So I see that there is a plus sign there. It is an ellipse. It got shifted 4 right and 1 down. So that's why my center is at 4, negative 1. The A stretch is 2. The B stretch, the vertical stretch, is 4. So when I go to graph that, I would graph my center, and I would go 2 units right and left of that, and 4 units up and down from that, because that's the vertical stretch. Or horizontal stretch is A, vertical stretch is B. And then this one is another tangent one. So I solve for tangent, solve for secant, and then tangent squared plus 1 equals secant squared. I got a 1 here, so I subtracted the x plus 4 squared over 9. So now with this one, the center is at the x's got shifted 4 to the left, y's got shifted 7 up. So my center is at negative 4, 7. It is a hyperbola because of the minus sign. And this one, because the y squared comes first, it is the positive piece. It's going to open up and down. So you don't really need to draw the picture. You can just tell me opens up, down. And that's really all you need to know about that. You don't need to know anything else at this point. Okay, so that's the front side. I hope that cleared up a few things about the secants and tangents, and then maybe throwing some of these on your calculator and taking a look at where they start and where they stop. If you see something odd like number 3, just set your window and see what happens there.